Hey there, this is Matthew Perkins Coppola. I wanted to share with you about my moon phases handout that I use to help students to understand conceptually what's going on with the motion of the moon. First things first, in the diagram on the left side you see the incoming sunlight. The sun is 400 times farther away from the Earth than the moon is. And for that reason, any of those light rays that are coming in from the sun, we can assume are roughly parallel to one another, which is why all those light rays are coming in at the angles that they're coming in at, parallel to one another. I have 8 positions of the moon in its motion around the Earth drawn into this diagram. And I'm going to show you a couple of these, and then you'll go from there. You see that there are these square boxes that are next to the circles. The circles are representing the moon, and these square boxes are what would be seen by somebody on Earth who's looking at the moon at this particular time. So you start by filling in the moon circles, and then we can draw in what's in those boxes a little bit later. So I'm going to put my ruler down, and I note that the moon itself is actually a sphere. And so if the sunlight was coming in, the light would be coming in from the left, and it would mean that there is light hitting the left side of the moon, but not the right side. And so the right side of the moon is going to all fall into the shadow. Again, it's as if there was a sphere, like this one, and we shine a light on that sphere, and that light comes in from the left side and lights up the left half of the ball and leaves the right half of the ball in the shadow. So, what would a person looking at this from the Earth see when the moon is at this particular position relative to the Earth and the sun? Well, I'm going to rotate my paper. I'm going to rotate it so that now there's a little person standing on the Earth. I'll draw them in. And I'm going to draw them. There's their nose as they're looking to see. And that person looking out is going to see only the shadowed side of the moon. They're not going to see anything in this sky. To again demonstrate this with my styrofoam sphere, the sunlight coming in from that direction would mean that that person on the Earth would only see the shadowed side of the sphere. And so in the square box, there's nothing to draw. We're not going to draw a circle that's shaded in black, because when this new moon phase is in the sky, we certainly do not see a big black circle in our sky. In fact, intuiting that you have the sun and the moon in the same part of the sky together, you've probably figured out at this point that this new moon, if it was visible, would be up during the blue skies of the daytime. Now, the blue skies don't keep us from seeing the moon, but, as you might imagine, between the Earth and the moon is the atmosphere, which is close to the Earth's surface. And so if the shadowed side of the moon isn't giving off any light, we just see the blue light from the sun scattered in the sky, and we don't see any kind of shadow from the moon. The only time we would see a shadow in this case would be if something happened to come between our sun source and our moon was directly involved there. And as you notice, we get this little shadow that kind of represents what an eclipse event would look like. Most of the time, though, our moon just happens to be a little bit higher or a little bit lower than the sun when it's in this sun-Earth-Moon alignment. And so an eclipse doesn't usually happen. About once every 11 months or so, an eclipse will happen. But in the case of this solar eclipse, these, because the moon is so much smaller than the sun, or in this case, I didn't mean to talk about eclipses in this video, but when a lunar eclipse happens, that situation where, in that situation, the moon is back in this kind of position, and the sphere of the sun, or excuse me, the sphere of the Earth is blocking the sunlight from getting to the moon shadow is much, much bigger than the shadow that the moon would cast on the Earth. And so your lunar eclipses can last for a very long time, and they can be seen from many different locations on the Earth within a single eclipse event. Whereas a solar eclipse, for those of you who remember the one that happened just a couple of years ago, where that moon is blocking the light from the sun from reaching the Earth, in that situation, it only lasted in totality for a maximum of about 2 to 3 minutes from locations in North America. Again, a much smaller shadow that the moon casts on the Earth, as opposed to the one that the Earth would cast on the moon during the lunar eclipse event. I'm going to draw one more of these in this picture, remembering that we need this light to come in such a way that it is parallel. I'm going to have to move my light source a little bit. And we can see that this sun is going to hit this side of the moon. And a little bit of that is actually going to be visible from the Earth as we line up our sunlight and our moon and our Earth. A person looking at this event from the Earth, let's say that they're right here and they're looking up, when the moon has shifted to this position in its motion, is going to see something that looks like this, in which they look out at the moon, and this part of the moon is still shadowed, but this part is lit up. Being a sphere, when that kind of thing happens, it appears like a crescent. And this is how we get the crescent moon phase in the sky. Now, this is the view from Earth, and you'll notice I've got my paper all turned around now. So, in the box, what would that drawing look like? Again, the sunlight is coming in from the left. It's going to shadow the right side of the moon, the side that's opposite the moon in this drawing. And somebody looking at this from the Earth, I'm going to draw a little tangent line between the Earth and the moon, little dashed line. Okay, and what that person can see would be something like this. the person looking from the Earth would see shadow on that person's left and light on that person's right, which would look like this. We don't draw in the rest of this as shadowed, although we sometimes do actually see that happen. When that happens, we say that some light off of the Earth's atmosphere is reflecting out to the moon and giving us a little bit of earth shine on the moon. So if you ever see that phenomenon, that's what's going on. But typically, that light's coming in from the sun, striking that left side of the moon, and somebody from Earth looks up and they see mostly the shadow and then just a little bit sliver of sunshine. So that's it for this video. I'll do a second video demonstrating what this would look like with some ping pong ball spheres.